Hi class, Dr. Searcy back with you again, this time to go over the odd numbered problems for chapter 1. Remember that the goal here is for me to explain each of the problems to you and show you how to work them out so that you can then do the even numbered problems on your own. First thing I want to remind you of is that Chapter 1 is entitled An Introduction to Statistics, and this chapter is basically an introduction to what statistics are. So let's go over each questions, beginning with number 1. It reads that a researcher is interested in the texting habits of high school students in the United States. The researcher selects a group of 100 students, measures the number of text messages that each individual sends each day, and calculates the average number for the group. And so over here are the questions that we have for this. Question number A is asking to identify the population for this study. Remember that a population is everyone in a group that's being studied, right? And so as we read here, we're seeing that the population can be thought of as all USA high school students. What was written right here, students in the United States. So then question B is asking to identify the sample for this study. Remember that a sample is a group selected from the population. And we could write that out here as the sample being the group of the 100 students. So then question C is asking, the average number that the researcher calculated is an example of a blank. What is C? Well, we can refer to it as a descriptive statistic, right? Let's remember that descriptive is a type of measurement that we're going to use to organize and summarize the data. And that's what we've done here when we calculate averages, just like we talked about in the lecture notes. Another thing that we noted in the lecture notes is that we're also referring to this as a statistic because the statistic is something where we analyzed the sample. And the average that was created was the average of the sample, the 100 students. One other thing that you can note here is there is an asterisk next to this number 1. In the textbook, this is telling you that the answers to the odd problems can also be found at the back of the book. Okay, so let's go ahead and move on to question number 2. Oh, I'm sorry, we're doing only the odd problems, so we're moving on to question 3. And it reads, statistical methods are classified into 2 major categories, descriptive and inferential. Describe the general purpose for the statistical methods in each category. Well, so we went over this in lecture, but I'll go ahead and repeat it. Descriptive is where we organize and summarize data. We do things like calculate averages, and that helps us give us a sense of what the data is, right? If we're getting a sense of what the data is, that's getting the sense of it being organized and then summarized. Inferential, on the other hand, is where we use the sample data to make conclusions about the population. Now, I'll just note that I'm kind of being vague about these conclusions that we're making. This being the first chapter, I'm going to continue to be vague. And then as we get into what inferential statistics are, I'll stop being vague and I'll be more clear on what we mean by what these conclusions are. For right now, though, let's just realize that we have 2 different kinds of statistics, descriptive statistics and inferential statistics. So then we can go ahead and move on to question number 5, which says, describe the data for a correlational research study. Explain how these data are different from the data obtained in an experimental and non-experimental study, which also evaluate relationships between 2 variables. Okay, so remember in the correlation, we defined it as where a researcher is measuring whether 2 variables are related to each other. And so here, we could just write that as we can start to use that logic to help us write the answer. But the way I'm writing the answer for us here is I'm saying a correlation is where you have one group of participants and you're measuring two different variables with that one group. If you remember from our example in the lecture notes, we said that we were looking at BC students, right? So we were looking at a sample of students. And we went to that one sample, that one group of students, and we asked them the two different questions. How long they were a BC student and how depressed they were, right? So that's the two variables. And that's our logic for how we can run a correlational study using one group of participants with two variables. From there, though, we can also talk about what an experiment is doing. Here, we would say that in an experiment, we are generally using two groups of participants, and we're measuring one variable with those two groups. I really didn't get into the lecture, so I'll just kind of give you an example. Let's say we do an experiment, and in the lecture, I said that an experiment is where a researcher does something to a participant and then measures the reaction. And we were saying the thing that we were going to do was going to administer an antidepressant to some participants and then measure the effect on those participants' levels of depression. A way that would happen with two groups is you could say have one group that's referred to as the experimental group. And then you have a second group that's referred to as the control group. And what we would do here is we're going to expose both of them to the one variable, right? The one variable being the administration of the medication. And then we're going to watch their reaction. What we would do here, though, in this type of setup is we would give the experimental group the medication and we would not give the medication to the control group. And then afterwards, we would measure both groups' levels of depression. What should happen here is if the medication is effective, the depression in the experimental group should go down because they got an effective medication, while the depression in the control group should stay the same because they didn't get any intervention. They didn't get any medication to change how they feel. Okay, so let's go ahead and move on then to the next question, question number 7. Here, what's being asked is Stevens, Atkins, and Kingston, 2009, conducted an experiment in which participants were able to tolerate more pain when they were shouting their favorite swear words than when they were shouting neutral words. Identify the independent and dependent variables for this study. Okay, so first, let's just make sure that you're saying the researchers conducted an experiment here. Right? An experiment is where some researchers do something to some people and then they measure the reaction of the people. So what was it that the researchers did to the people here? Well, they basically gave them a way to react to pain. Two different ways. One way was they could have shouted their favorite swear word, or they could have said some kind of neutral word. Right? And the idea here is that when someone experiences pain, if they get to swear as opposed to just uttering some neutral word, swearing is going to make them feel better than just saying some neutral word. Okay, so the question that we have here is, what is the independent variable and what is the dependent variable? Well, what you should be getting from this is that the independent variable was the word type that the participants got. Either they got to swear or they got to say the neutral word. So then the dependent variable, right? Remember, the dependent variable is where we measure the reaction of the participants to the independent variable. So the dependent variable here would have been the amount of pain tolerated. And what should happen is that because it feels better to swear than it does to say some kind of neutral word, the participants should have tolerated more pain when swearing than when uttering the neutral word. Okay, so let's go ahead and move on to question number 9. Here we're saying Gentile, Lynch, Linder, and Walsh, 2004, surveyed over 600 8th and 9th grade students asking about their gaming habits and other behaviors. The results showed that the adolescents who experienced more video game violence were also more hostile and had more frequent arguments with teachers. Is this an experimental or non-experimental study? Explain your answer. Okay, so some researchers did some stuff. Question is what they did an experiment or a non-experiment? I'll just go ahead and give you my answer. And I'm saying this is a non-experimental study. How is that the case? Well, the researcher is not doing anything to the participants, just surveying them. Right, so maybe we should clarify here. If a researcher goes and asks some participants some questions, right, like a survey, that is not an experiment. Just asking participants questions isn't an experiment because you're not doing anything to the participants to cause any kind of change in them, to cause any measurable reaction. You're just asking them a question and they're answering the question, right? So let's just remember that if you're just asking participants a question, you're not doing anything to them, therefore you are conducting a non-experimental study. So moving on to question number 11. A research study reports that alcohol consumption is significantly higher for students at a state university than for students at a religious school or religious college. That was in Wells, 2010. Is this study an example of an experiment? Right? So again, was this an experiment? Was this a non-experiment? Explain why or why not. First, I'll give you my answer. This is a non-experimental study. Why? Because the researcher is comparing pre-existing groups to each other. Again, the researcher has not done anything to the participants to cause any kind of change in them. Whatever was done was already done when the students chose the school to go to, right? So the students either chose to go to the state university or they chose to go to a religious college. The researcher didn't do that. The students did that on their own. So because the researcher didn't do that, the researcher is conducting a non-experimental study. Let's go ahead and move on to question number 13. And here the question reads, a tax form asks people to identify their annual income, number of dependents, and Social Security number. For each of these 3 variables, identify the scale of measurement that probably is used and identify whether the variable is continuous or discrete. Okay, so we've just been given 3 different kinds of numbers. Let's see, the first one was their annual income. Second one was the number of dependents. And the third one was the Social Security number. Now the question is, for each one of these types of numbers, is that number a continuous number or a discrete number? Right, and so let's just kind of, before we even answer the question, let's just kind of remember what we said about discrete versus continuous. What we said was discrete numbers are indivisible numbers. Indivisible. And continuous numbers are numbers that are divisible. And remember the thing we said, that was the difference between these two things is that these numbers cannot be divided. You can only have a whole number or nothing. Continuous numbers, however, can be divided. So continuous numbers can be presented in terms of fractions or decimals. Right? So like with a continuous, you can have like a half of something. With a discrete, you cannot have a half of something. So, okay, let's look to see what's what here. The first type of number is the annual income. That is a number that is continuous. Why is it continuous? Because you can express income in halves. For instance, you could say, I got paid $1 million last year. But you could also say, I got paid $1,000,050 last year, right? And because you said 50 cents, you've divided that dollar in half. And because you've divided something, you've got to say that that number is then continuous. Let's compare that to, say, the number of dependents, right? So number of dependents, that is like basically how many mouths are you feeding? How many kids do you have? That kind of thing. Is that number discrete or continuous? Well, the logic here is that you can't have half a kid, you can't have half a dependent, so then that number is going to be discrete. What about Social Security numbers, right? So when we look at Social Security numbers, they are numbers, but they're really more names rather than numbers, right? They're just kind of like labels. And you can't have a half of a Social Security number, so therefore a Social Security number is not divisible, and that means then that a Social Security number must be discrete. Okay, let's go ahead and move on to question number 15. It says, Knight and Haslam, 2010, found that office workers who had some input into the design of their office space were more productive and had higher well-being compared to workers for whom the office design was completely controlled by an office manager. For this study, identify the independent variable and the dependent variable. So right off the bat, we're seeing this must have been some kind of experiment. Why must it have been an experiment? Because it's got an IV and a DV. Okay, so let's try and figure out what the IV was then, right? What did the researchers do to the participants? Here we're saying that they gave them two conditions to work under. One condition was where they had some input into the design, and the other condition was where they had basically no input. The design was completely controlled by an office manager. So got to control the design, didn't get to control the design. That to me looks like an independent variable. And the way that we could express it is the independent variable is the amount of control over office design. Either some control or no control. Okay, so what was the researcher looking at? What was the researcher looking at that this would affect? Here we're seeing that the effect, what they were looking at was productivity and well-being, right? So the question was, did amount of control affect how productive and happy the participants were? Therefore, since this is what this was influencing, the dependent variable must be productivity and well-being. Okay, so let's go ahead and move on to question number 17. Here we say, Ford and Turok, 2008, found that motivational signs were effective in increasing physical activity on a college campus. Signs such as, step up to a healthier lifestyle, and an average person burns 10 calories a minute walking up the stairs, were posted by the elevators and stairs in a college building. Students and faculty increased their use of the stairs during the times that the signs were posted compared to times when there were no signs. Okay, so this is the description of a study. Let's look at the questions for our description. Question A is asking to identify the independent and the dependent variables for this study. So again, we're saying this must have been an experiment because they're asking what the independent variable and the dependent variable was. Remember, so the independent variable is what the researcher did to the participants. And as far as I can tell, what the researchers did was they either put up signs or they put up no signs. Right? So let's think of that as the independent variable. The way I'm expressing it is the independent variable was whether or not signs were posted. Okay, so we got that taken care of. What about the dependent variable? What's the dependent variable in this study? Well, what I have written down is that it was the amount of use of the stairs, right? And we're getting that because we're saying students and faculty increased their use of the stairs during times that the signs were posted, right? So the posting of the signs caused this reaction. They increased how much they used the stairs. Okay, so then that leaves us with question B. What scale of measurement is used for the independent variable? Now remember, with scale of measurement we're talking about from the lecture is that noir system. I wonder if anyone is able to remember what noir stood for. Okay, let's see if Dr. Searcy remembers. N was nominal, O was ordinal, I was interval, and R was ratio. But Dr. Searcy doesn't feel like explaining what each one meant. Instead, let's just say, okay, what scale is this? So which one of these was this study? We're saying that it was that the posting versus the not posting was nominal, right? Because remember, nominal was where you're just organizing the data by category. There were just two categories. Either the signs were up or the signs were not up. Okay, so that's the answer for question number 17. Let's go ahead and move on now to question number 19. And this is saying that for the following set of scores, find the value of each expression. Okay, so just make sure that we see what we're talking about here. Each one of these statements is an expression. Remember, an expression, it's kind of like a mathematical statement, but a mathematical statement without an equal sign, right? Otherwise, it would be an equation. Let's also get a sense of what this is. This is a table of data. And I just kind of want to describe how the table of data is organized. It's saying that this is the data that we got for the X variable in some study, right? Remember, X stood for the scores for the first variable, right? So these are the different scores that different participants gave us, maybe like an answer to a question. Let's go back to our example from lecture, where I went up to people and I asked them how long they had been a BC student, right? A Bakersfield College student. This could be individual answers that each of those students gave me, right? So this 3 would represent one student saying that they had been in BC for 3 semesters. Another student saying, I've been here for 2 semesters. Another student saying, I've been here for 5 semesters. Another student saying, this is my first semester here. And then this last student is saying, I'm in my 3rd semester. Thank you very much. Okay. Right, so this is how we organize the data. Now, the thing that we want to get at is what we do with these sigmas, right? So remember, we introduced sigma at the end of the lecture notes for chapter 1, and we say that sigma means sum of, right? It's basically the sum of whatever it's in front of. And so now it's saying, what is the sum of the X column squared? Well, what we have to do is now organize the data to answer each of these. And so that's what I'm going to show you how I've done it over here. I basically took the data and I just rewrote it. One thing that I did was I said, okay, if this is my X column, we can get a sum of X, right? And that sum of X, what is the sum of the X column? Well, what we do is we add that column up, and we'd say sum of X is 14. Unfortunately, this does not answer any of these questions. So then what we've got to do is now dig into trying to answer each of these. Let's say we'll start with item A. What is the sum of X squared? Basically what they're saying to do there is to take that X column and now square each number in the X column like this. Okay, so I've taking my x's, and I'm going to square each one of them. And you know that when you square something, you're basically multiplying it by itself. So I'm creating this new column of numbers, and the way that I'm getting each number is I'm just going to the previous column saying that number times itself is 9. 2 times 2 is 4. 5 times 5 is 25. 1 times 1 is 1. 3 times 3 is 9. Then what do I have to do after I've done that? I have to add all of those scores up for the x squared column, and that is what gives me my first answer. Sum of x squared is 48. How am I getting that 48? I'm taking each of my x values, squaring them, and then adding up the sum of those squared values. Now let's look at question B. It's kind of asking the same thing, but it's throwing some parentheses in there. So it's asking a different question now. Now what it's saying is, take that number that you got for the sum of x and square it itself, right? When you see the parentheses next to the exponent, it's saying the exponent is telling you to square whatever is inside the parentheses. So we've already figured out what the sum of x is. That was this value there. Now all we have to do is take that sum of x and square it, multiply it by itself. The way that we're doing that is right here. We're saying, oh, the sum of x is 14. So I'm going to take that 14, multiply it by itself, and that gives me 196. So sum of x squared is 196. Okay, but then there's question C. Here they're saying, sum up all of the x's minus 1. So now what we have to do is create another column called x minus 1. And what we're doing here is row by row, we're just adjusting each of our numbers. So the original x was 3, but we have to create a column where it's minus by 1, so it gives us 2. And so on and so forth down the list. 2 minus 1 is 1. 5 minus 1 is 4. 1 minus 1 is 0. 3 minus 1 is 2. Once we've created that new list of numbers, we sum them up. And that is how we get this. That's how we get our answer for question C. Sum of x minus 1 equals 9. Right? And that's our 9 that we got right there. Okay, so then question number D is now saying, oh, okay, well, take those x minus 1s and square them. Okay, so what are we going to do there? We're going to say, okay, we're going to create another column, and we're going to call that another column x minus 1 squared. And what we're going to do is we're going to take each x minus 1 that we created, and we're going to square each of its values. So we got 2 in this column. 2 squared is 4. 1 squared is 1. 4 squared is 16. 0 squared is 0. 2 squared is 4. From there, we're going to sum up the values in this column. Gives us 25. And so then we say the sum of x minus 1 squared is 25. Okay, let's go ahead and move on to the next problem now. The next problem is taking the way that we organize data a little bit further. And I'll just kind of explain how I mean that. So here we're saying, now we've got 2 scores, right? We've got an X score and we've got a Y score. And for each score, we got a list of values for each one. Right? They even gave us a nice handy dandy little guide showing who answered what question. Right? So what happened was, this could be like that correlational study that we did earlier, right? Where X was length of time as a BC student and Y was level of depression. Right? So here we can say, oh, student number A said they've been a student for 3 semesters and 4 is how depressed they were. Student B was around for 0 semesters, and they're up to a 7. I don't know how you could be around for -1 semesters. But they're at a 5. And then the participant number D has been around for 2 semesters, and they're also pretty undepressed. Hey, this actually agrees with what I was saying earlier about newer students being more depressed. Anyway, so I hope you see how this table is working. Now we have to answer the questions that are involved with it, right? So first we've got a question asking, what is the sum of x? Well, all we have to do is take those x values in that x column, add them up, and we're seeing that we got a 4. How did I get that 4? Well, we go 3 plus 0 is 3, plus a -1 is 2, plus 2 is 4, right? So then we could say, okay, sum of x equals 4. Next question is, well, what is the sum of y? So all we got to do here, just take all those y column values, add them up, and that gives us our sum of y. Third question is, but what is the sum of x times y, right? When two values are next to each other, it usually means to multiply them. So what we've got to do now is create a column for that, a column of x times y. When we do that, we go across the rows. We see 3 times 4 is 12. 0 times 7 is 0. -1 times 5 is -5. And 2 times 2 is 4. Once we've created that x times y column, we then add those numbers up, and we say our answer is the sum of x times y is 11. Okay, moving on to question number 23. So now, this is the last question in the chapter. Yeah, woo! And the question is saying, for the following set of scores, find the value of each expression. So again, we've been given X list of scores. Looks like there were 4 participants here, and each one gave us a score. Now we're being asked to calculate these values. Looks like we already know how to do A. All we do is take our X values and square them. Right, so that's what I've done here. For my X squared column, I'm saying that 1 times 1 is 1, 6 times 6 is 36, 2 times 2 is 4, 3 times 3 is 9. Once I've created that new column of scores, I then add them up, get that 50, and that 50 is what we get for our answer of what is the sum of x squared. But now let's go ahead and move on to B. B is now asking a different question. Now it's asking, take that sum of x and square it. Okay, so what is the sum of x? The value in the parentheses is where you have the x column. We've summed it, and it's 12, right? So the sum of x is 12. Let me do a better sigma there. Let me do a better sigma altogether. Okay. X equals 12. Okay. So now we have a sum of x being 12, but the question is, what is the sum of x squared? So what we have to do for B is take that sum of x, multiply it by itself, and then its answer is going to be the answer to this, right? So sum of x squared is 144. Okay, so for question C, what is the sum of x minus 3? So again, what we have to do is we have to create a new column called x minus 3. And we just basically have to take each value in the row, and in the x row, and subtract 3 from it. So 1 minus 3 is negative 2. 6 minus 3 is 3. 2 minus 3 is negative 1. 3 minus 3 is 0. Now that we've created this new column, we need to add all the values up in it. They add up to 0. And so for C, we're saying the sum of x minus 3 is 0, because that's what we got right here. So then we have one last problem here, and that is, what is the sum of x minus 3 squared? Okay, so what we have to do is now take that x minus 3 column and square all the numbers in it. Right, so we're going to create a new column to do that. We're calling it x minus 3 squared. So we're taking the x minus 3, we're going to square it. It's negative 2 times negative 2 gives us a positive 4. 3 times 3 gives us 9. Negative 1 times negative 1 gives us a positive 1. 0 times 0 gives us 0. So now that we've created that new column, we add up the numbers in that column. They come up to 14. And so we say the sum of x minus 3 squared is 14. That's it. Thank you very much for your time.